Another way to prove quadratic expressions, its factored form and its trinomial form equivalent is this way. Let's say we have, okay, give me one second. Let's say we have the expression n squared plus 11 n plus 24. Okay, we can go. Let's go ahead and use x since that's what we're used to. So let's say we have x squared plus 11x plus 24. Okay, and it says it wants us to factor this. Okay, let me go ahead and write the instructions here just so you remember. It says it wants us to factor this, and it wants us to show that the original expression and the factored form have the same values, for x is equal to 0, 1, and 2. Okay? So it says, for this quadratic expression here, show that the original expression, which is this here, and the factored form have the same values for x is equal to 0, 1, and 2. So basically, we're proving that this expression, the original expression, and the factored form are equivalent to each other, okay, by substitution. So let's go ahead and get started with that. If we factor this, we want to multiply to 24, but we want to multiply to positive 24, but add to positive 11. So let's go ahead and do that. So we take the factors of 24, and we see what their sum brings us here. So let's see, we're dealing with, let's take 1 and 24. They'll add to 25, so that's not what I want. We'll take 2 and 12. They'll add to 14. That's not what I want. We'll take 3 and 8. Well, these will add to 11. That is what I want. So we're actually looking at taking this line here. I'm sorry. We're actually looking at taking... We're actually looking at taking this line here. Okay, 3 and 8 is our factors. Okay, since it's all positives here, you know, we're going to have all positives in our factored form. So what is our factored form? Okay, well, since I'm done with this up here, I don't need this anymore because I've already found my two factors. Let's look at it. So we have our two factors, which will be 3 and 8. Okay, let's go ahead and erase everything. So 3 and 8. So if we're factoring the product of two binomials, which we are, we know x will go here and x will go here. And since they're all plus, everything's going to be positive. We'll substitute a 3 and an 8. Okay? Now, so basically what we're going to do to prove these two, the factored form, let's say this is the factored form. Factored form. And then this is the original form. Okay? So we're going to prove that the original form and the factored form have the same values for x is equal to 0, 1, and 2. So let's start off. Okay. Okay, so we should really go ahead and make a chart here, but let's go ahead and scroll down. I'm going to run out of space if I don't. Okay. See if we can get a little bit more space in there. Okay, so let's go ahead and draw a chart here. Okay. And here are n values. And it said for n equal to 0, 1, and 2. So 0, 1, and 2. Perfect. Alright, now let's do this one for the factored form here. Let's put that in yellow. Alright, just draw the chart here. And 0, 0, 1, and 2. Perfect. Okay. So in here, what we'll have, let me get the color. We'll have n, our values of n, which would be 0, 1, and 2. And then we'll have our expression up here, n squared plus, let's see, n squared plus 11, n plus 24. And then it will have n over here plus our factored form, which would be n plus 3 times n plus 8. Okay? Now, let's go ahead and do some evaluation here. If we take n and we substitute, so let's see, we take 0 substituted for n. So everywhere we see an n, we're going to put a 0 for this for specific one. So 0 squared plus 11. Well, let me do it this way. Okay, let's do it like this. Let's do 0 squared plus 11 times 0 plus 24. Plus 24. Well, this will equal to 0 squared will be 0. Plus 11 times 0 is 0. So this goes 0 plus 24, which is equal to 24. Okay. Now let's go ahead and do this. Let's substitute a 1 in for let's substitute a 1 in for n in this expression here. Okay, I'm actually putting n. It should be x. This variable should be x. I'm sorry. I'm using a different variable here. It should be x as our variable. Let me change that. X should be our variable. Our variable should be x, not n. It should be x. So if I'm getting you confused, just know that we're just changing instead of the variable being n, we're actually making it x plus 11x. Okay, then this should be x, x, and x. Okay. All right, so let's go ahead and finish it. So we're going to substitute basically a 1 for every x that we see. So it'll be 1 times, so it'd be, let's see, yeah, it'd be 1 squared plus 11 times 1, close parentheses, plus 24. Okay. So this will be 1 squared, which would be 1, plus 11 times 1, which is 11. So 11 plus 1 is 12, plus 24 will give me a 36. Okay. And then last one, 2. Well, let's see. So we have, let's substitute a 2 in for every x that we see. So we see an x there, so it'd be 2 squared plus 11 times 2. Okay, plus 24. This will be equal to 2 squared will be 4 plus 11 times 2, which is 22. So 22 plus 4 will be 26, and 26 plus 24 will be 66. Yep, 22 plus 24. Yep, that'd be 66. Okay, so we basically have our values here. I'm sorry, that'd be 50. What am I doing here? That'd be 50. 50. Okay, so now that we have our values, here, let's go ahead and see if we get the same values for x is equal to 0, 1, and 2 in our factor form to prove that these are equivalent. If we do, then we can go ahead and say that these two in the factor form is equivalent to the original expression. Okay, so we'll take and we'll put our 0 in for x that we see. So we see an x right there, so we'll put a 0 plus 3. Okay, multiply times 0 plus, what is that? Plus 8. Okay, plus 8. Let me make sure I'm writing my 8 out. Okay, so this will be 0 plus 3, which would be 3, and then 0 plus 8, which will be 8. Well, we're going to actually end up multiplying these together, if you see here, because we'll end up getting 3 times 8, which will be 24. Okay? And that's the same thing as right here. Right? Well, let's keep going. Let's go ahead and let me get a different color here. So we'll take, now we're going to substitute a 1 in for the x. So it'll be 1 plus 3 multiplied times 1 plus 8. All right, let me put that 8 back in the search. 1 plus 8. Well, 1 plus 3 is 4. Then 1 plus 8 is 9. And 4 times 9, that'll give me a 36. And that's the same thing that I have here. So far, so good, right? We just have to do this last one. Then we can actually prove that the factored form and the original expression are equal. Okay, so let's take now we're going to substitute a 2 for every x that we see. So 2 plus 3 multiplied times 2 plus 8. 2 plus 8. 2 plus 3, that'll give me 5. Then multiply times 2 plus 8, which will give me 10. So 5 times 10, and I get 50, which is the same thing that I have here. So since these values are the same, in our question here it said, factor this and show that the original expression and the factor form had the same values for x equals 0, 1, and 2. And we did show that they have the same values. So therefore we know that the factored form, therefore we can say, okay, let me write that. We can say, let's see. So we can say that the factored form is equivalent to the original expression. So in this case, it'll say x squared plus 11x plus 24 is equal to x plus 3 times x plus 8.